Welcome to the SNIA virtual booth. Today I'm going to walk you through an example of interacting with a redfish and swordfish implementation. I'm also going to show you a few highlights of a couple different configurations. One, how to navigate through and look at a standard storage device, in this case an NVMe drive. In the second case, we'll be looking at a configuration that is a work in progress of a joint effort between not only redfish and swordfish, but also working with the Open Fabrics Alliance and Gen Z to develop the Open Fabrics Management Framework, an open source framework to manage all sorts of different storage fabric technologies and fabric technologies using a redfish and swordfish based interface. For this first demo section, we'll be walking through an interaction with an Ethernet attached drive. This is actually done in an emulator on my system. I'm going to be interacting with the system using Postman. This is a standalone REST client that we can use to interact with our redfish and swordfish interface. First thing command we'll do is just a get of what we call the service route. It's a pointer to your web server interface with the /redfish/v1 hierarchy added. You can see here the body of the get. It shows there are registries, session service, storage, instance, and chassis. That's where we'll focus. In the redfish and swordfish hierarchy, there's basically a pairing of information where you have your physical information in chassis along with logical information. And in this case, for a storage device, it's in the storage collection. I can click on that in this interface and have it brought right up. We're now in that storage collection. This is basically a set of all the objects in the system. We have one instance here. So let's dig down on into that one. So again, we select that one and work our way down. You can see here, you've got at the top information metadata about the URI, schema type to follow, and then we get into what are the objects and properties in the system. This is an NVMe device, so those are actually NVMe controllers. We'll go in and look at some of the properties there. There's also a link to volumes down here. That's where we'll find the information about the namespaces. There's also this mapping over to an instance in chassis to find the physical components and physical properties of this object. So let's go look first at the controllers. This is an NVMe device, so these are logical physical controllers. Again, we get to a collection, says it's only one. We'll work our way down into that next device. There's a lot of properties in here that talk about this NVMe controller. Everything from firmware version, links back over to the namespaces that are exposed through this controller, and sets of a bunch of NVMe specific properties, including supported controller protocols, NVMe down here, and the overall status of this controller. All right, let's go back to the volumes. Well, we can shortcut that and just look at this, that the volume is here, or we can navigate our way through the hierarchy. We'll just go over here and look at the namespace associated. And you see that same behavior, the metadata at the top, and then a lot of related properties. Some of this data is similar to what you would expect to see from a traditional volume, like the capacity information, but others are much more specific to NVMe, like these namespace properties down here. We've navigated our way around on the logical side. Let's pop over to the physical side. We'll go back up all the way to that service route and just go to the chassis. Chassis is a general construct. You can see we have one here. We'll drive down into that, where we will see a lot of properties associated with this again. Because this is an Ethernet attached drive, there's network adapter information in here. There's thermal information about the device itself. And then there's a drives object in here in this drive collection. Since this is a singular drive, there's going to only be one of these. This is where you'd see a lot of very similar typical information. Block size, is it encrypted? What's the manufacturer model, part number, physical location, if this is mapped from the system it's in. So there's a ton of information in here. It's very consistent. It's both very consistent with traditional storage devices as well as having all of its own unique NVMe attributes. So we've walked a little bit around this Ethernet attached drive, which is a typical storage device. What does it look like and what are we working on in a broader model? I brought the system back up with a different underlying model underneath it. This will actually show us some rather interesting attributes like what's going on in the service route. So let's walk our way through this service route for this instance. There's some interesting things in here. If we go again, we'll start with the chassis and look on this side. Let's start by taking a look at the chassis instance. So let's go to chassis 1 and see what's in that. There's different attributes in this because this is working as part of a model for a storage fabric. And in this case, it's actually modeling a Gen Z fabric. So you can see a lot of those same constructs in there, but also a lot of new pieces like media controllers and memory domains model. And we have 4 media controllers in this configuration. We'll go look and see what a media controller is. You could glean a lot from just looking at the properties. This media controller has links to the endpoints, which is endpoints are used for connectivity, and for the memory domains. As we work our way again a little bit around this model, we can go over to the fabric and see connectivity information. So we have a couple of different fabrics in here. We'll take a look at fabric 2. This one really shows connections, endpoints, switches, and zones. This is combining 2 different things into one fabric. One of those where you use the connections is access rights. That's presenting those using the combination of connections, endpoints, and zones. When you're talking about mapping your physical connectivity, you do that through the switch model and a combination of switches, endpoints, and zones. So now you can see in this model, we have expanded our fabrics to cover connectivity in addition to simply modeling the logical and physical attributes of a single device. We're now highlighting all this connectivity. If you want to see a much bigger and more comprehensive Gen Z demo using Redfish and Swordfish interfaces, check us out at Supercompute in November 2021.